everybody. From today we will be starting first law of thermodynamics and some thermodynamic processes related to that. So we first have to learn first law of thermodynamics. Before this first law of thermodynamics, we have learned about zeroth law of thermodynamics. The zeroth law of thermodynamics was related to the thermal equilibrium. Now we will start a new kind of laws. So let's learn this. First law of thermodynamics. Alright, so I want to tell you one fact. What is the fact? In reality, it is not a fact, it is just I am telling you about this law. The law, first law of thermodynamics. Sorry about that. Thermodynamics is based on the law of conservation of energy. So we have learned about law of conservation of energy in the chapter 11 when we are listening thermodynamics. Don't be confused, we have learned about this conservation of energy in work and energy chapter concerning. Alright, I don't need to explain this to you. So when you will learn the law, you will definitely understand that how this law is based on conservation of energy. Now I want to describe some basic terms to describe this first law of thermodynamics. Oh, is it a very advanced one? No, it is not very advanced. I'm just telling you. This symbol is known as del. That means del Q is total heat supplied to the system. So that's what terms I'm about to tell you. Now there is another thing. Del W, total work done on the, and we see that it is on the system, not by the system. Alright, the meaning of del W is total work done on the system. Now there is another term, du. Its meaning is change in inertial energy. So you got to understand both of these three terms to understand the first law of thermodynamics. Now we'll come to the definition part. The definition is very slow. Then the first law of thermodynamics states that del Q is equal to del W plus du. And just this is the law, there is no derivation about it. So this is very important because in other topics like thermodynamic processes it will be used very much. So that is it for you. This is the formula part. Now you just note it down. I'm going inside. Alright. I hope that everybody notes it down. Let's clear it off. we have completed the first topic of ours, first law of thermodynamics. Now we move to thermodynamic processes. Alright, so there are four types of thermodynamic processes which we will be discussing it on this video. Isopodic, isothermal process. And adiabatic process. These are the three processes. There is another one. Now isobaric process. Alright, you can note it down because now I'm going to clear it all. We will start from the first process. Sorry about that. Isopodic process. So what happens in this process? There is something or the other happening in all these four processes. So in this process, in isopodic process, volume is empty, constant. In this process, volume is constant. What does that mean? That change in volume is zero. That means delta is zero. And then one term can be defined as W is equal to P delta V. P multiplied whatever the value of P is, delta V is zero. That is work done is zero. Derive that what is the work done in isopodic process. In isopodic process, work done is zero. Alright, so applying first law of thermodynamics. I told you that this is going to be equal. Del Q is equal to del W plus du. That means that total work done is zero. That means that del Q is equal to du. This is another important derivation. Alright, so you can note it down because I'm going to erase it. Okay, erase this. Del can also be written as d. That means dq is equal to du. Alright, what is the d can also be written as delta, so formula of delta u is NCV delta T. And there is another formula. Can anybody tell me? Another formula is delta U is equal to NFR delta T by 2. Okay. So what we have to do? There is no derivation of this formula. We have to find CV. Formula of CV. So what is it? NCV delta T is equal to NFR delta T by 2. Okay, delta T cancels delta T, N cancels N. That means CV is equal to F4 by 2. That is right. has come. So this was another derivation. CV is equal to F bar by 2. These are very important type of formulas of the process. First process, isochloric process. Alright, now we want to learn. Now we want to learn about process equation. Process equation is a simple equation used for the same process. The process equation of isochloric process is PV is equal to K. Alright, can anybody tell me that? Is it true? I am giving you some time. The PV is equal to K. Is it the process equation of isochloric process? No, it is not the process equation of isochloric process. It is the process equation of isothermal process. Oops, I tell you about the next topic. Alright. So over here, the process equation is P by T is equal to K. Now this is true. Definitely. I hope that we will fall for it. Well, what is P? P is equal to pressure and T is equal to temperature and K is some constant. We learn about process equation, we learn about the formulas. Now what else do we have to learn about? Yeah, we have to learn about another thing. This is a Faraday formula. If a system undergoes through a process A with pressure, volume and temperature to be T1, G1 and T1. Okay, so it will be more proper that we don't write V1 but V because volume is constant in this process. 2 process B with pressure, volume and temperature to be P2, G2 and T2. Not V2, just V because it is volume is constant. Then what is the process equation for? Process equation is this: P by T equal to constant. That means that there is nothing related to this. To the P1 V and T2, P2 V and T2. Then the T1 is equal to P2 by T2. Okay, this is not the final concept from land. We have to understand this. If we will just continue like this is very important one, it is used very much. That means let me explain you. Okay. Let's say this is a container, this is the system, gas, pressure, T1, T1. This is the condition over here. It goes from another condition, T2, V and T2. So when this type of process occurs, then P1 is equal to P2 by T2. This is what it is. This equation is trying to say. Okay, I'm giving some time to note this down. Okay, so I hope you all wrote it down. I'm going to erase it, but before I want to tell you one thing that about some specifications of these C and F. F is degree of, and C is molar specific heat capacity of gases. So yeah, now let's proceed. Okay, now we move to isothermal process. So what happened in this process? As in isochloric process, what happened was volume is constant. Let's see in isothermal process, temperature of the gas remains constant. That means what? Delta T is equal to 0. Temperature is constant. What does it derive that? The inertial energy of the system is constant. What does that mean? Change in inertial energy is 0. That means du is equal to 0. Applying flow. That is formula of flow. That means that first law of thermodynamics. I'm just trying to save some time. Don't do it in exam, otherwise you will be punished. Okay, so about 4, what does it say? Del Q is equal to du plus del W. That means del Q is equal to del W. Okay, so we finally something between the heat and the work done. So just erase it. del Q is equal to del W. Okay, now we will come to process equation. What is the process equation of isothermal process? Let's do it over here. The process equation of isothermal process is, I have told you before, PV is equal to K, where P is equal to pressure, V is equal to volume, and K is some constant. So this is all about the process equation of it. Now we will come to the theory based formula. If a system undergoes through a process A with pressure is not constant, volume is not constant, that means P1, V1, the process with A with pressure, volume, and temperature to be P1, V1 and T1. What is constant over here? T. That means it is not T1, it is T. To P with pressure, volume and temperature to be T2, V2 and T. Then what is the equation? P1 V1 is equal to P2 V2. Alright, this part is the equation part. You can note it down. Now we'll come to its slope between P and V, that is pressure and volume. So, is this pitch okay? Yeah, it looks like not. I have to erase it. So you can note this part down. Now, solving it. Slope of PV Let's first draw a simple diagram of it. This is pressure, this is volume, this is the case, this is point A, P naught, D naught, P naught, not P naught, P, P, V, and same P. The pressure is constant. I don't have to write it. It is isothermal process. Okay, so what do we do now? What we do on all of this is that the process equation is PV is equal to K. Yeah, I have to find the slope of PV curve. Try that for differentiating both sides. Differentiating both sides. What will happen? I hope you have learned what differentiation comes. Okay. So what will we do? V dP plus P dV is equal to 0 as it is constant. That means that V dP is equal to minus P dV upon V minus P by V is equal to dP by dV. That means P by V is equal to minus dP by dV. Is it clear to everybody? That's why process equation is very important, and we derive slope of P versus V graph. Just note it down and which side. Okay, so I'm going to move it up. Let's try to type it back. Second, isothermal process, and work done by the gas in isothermal process is given by. Let's just put it down. P2V2 ln. Do you know the value of ln? It is something like 2.303 log to the base 10. You can check it out. Yeah, was I right? I would have said of course right. So P2V2 ln, and then what do we say? P1 by P2. It can be written in other forms like 2.303 log base to the 10 P1 by P2. But this was the formula for work done in isothermal process. So I'm going to erase it now completely, and it is done. Now we'll go to adiabatic process. Third. Adiabatic. Sorry, I wrote it wrong. Adiabatic process. Okay, what is constant over here? There is nothing constant. We can just say about it that heat supply or taken by the object is 0. That means it is thermally insulated. Q delta U is equal to 0. Okay, so now what is its process equation? We directly come to process equation over here. It is the process equation of adiabatic process is P power gamma is equal to K. Okay, well, what is this power? So let's first describe all the other terms. Is pressure, V is now gamma is Cp by Cv, which is always greater than 0. Right now, and K is some constant. Everybody understand this, right? Everybody understand it. Then we will move to our theoretical based type of derivation. If a system goes through a process A with P1, V1 and T1. I am not writing pressure, volume and constant P1, V1, T1, not like this. You will write it in your notes. I am trying to save some time of my own here. To V with P2, V2 and T2. Then the equation is then the equation is P1 V1 to the power gamma is equal to P2 V2 to the power gamma. This is again another equation of it. Should just note it down because in adiabatic process this is the highly weighted portion from which most of the questions are asked. So note it down. Okay, so now we will discuss about slope of PV curve. Slope of PV curve. Slope of P to V. What does that mean? Oh, a spider go away. Yeah. What is the slope of PV curve over here? What is the process equation? PV to the power gamma is equal to constant. That means differentiating both sides. E into y and v to the power gamma 1. Sorry, it is gamma, not y. I was writing here y. That's what it's reading. So p gamma into v to the power gamma minus 1 plus. Are we doing anything wrong? No. V to the power gamma into dv. dv pressure. Now everything is alright. It's equal to 0. P2 V. How will we derive V over here? Can anybody tell me? Anyone try to describe it to me? Think for a second. Okay, so now differentiating, what will happen? P gamma v to the power gamma minus 1. Then dv is a plus v to the power gamma dt is equal to 0. Okay. P now v to the power gamma P gamma v to the power gamma minus 1 into dv plus not plus sorry about that, it is not going to be plus. Then what will happen is equal to v to the power gamma dt. Then minus over here. Then dt by dv is equal to minus gamma into p by v. Problem was solved. Yeah, problem is solved. Now what can we do? It can also be written as this is the slope of p that v. Now there can be also a relation that what is over here? Slope adiabatic. Yeah. Slope of isothermal E. P dot B equal to slope of isothermal multiply gamma minus gamma is equal to slope of adiabatic P that we and P that we. Is it clear to everybody? Is it clear to everybody? You see, this should be clear, right? Okay, I think just erase it out. Now we will discuss some of the formulas. Like formula 1 is very important. V2 minus T1 U1 by 1 minus gamma. Is it clear to you what is the formula? Is it clear to you what is the formula? It is a very important formula and very vast various of it, but I won't tell it to you because I don't want to confuse you all. You guys have noted down, but I will erase it for a second. But I need some space. Okay, now we will discuss some other formula work done. What we generally know is that W is equal to N R delta T by 1 minus gamma. This is another formula which can also written as N R T2 minus T1 by 1 minus gamma. This is another formula. Let's note it down. These are very small formulas. That's why I'm telling you that in reality these are very important, but these are very small formulas. That's why I'm just telling you. Okay, so now we will come to the formula of delta U. Delta U is equal to NR T2 minus T1 by 1 minus gamma. Is it just the same formula as it is? Yeah. This is the same formula as of, oh my, work done. Work done, that means is equal to initial energy. Change in inertial mass. So this was all about adiabatic process. Now we will be moving to isobaric process. So I hope that you guys remind it all. Alright, this is it all. There's no need for more. Now we will be moving on our fourth part, which is isobaric process. Isobaric. What is constant in this process runs again? So in this process, isobaric process. What is constant? Volume is constant, heat is constant, temperature is constant, all of these are constant. Pressure. Pressure is constant. That means delta T is equal to 0. Okay, this is a very important part. You should just understand it that there is a very big role of pressure, like work done. When pressure is 0, what can we say? Work done is equal to 0. Here we get it on. Yeah, looks like we get it all. Now we'll come to the process equation. What is the process equation? The process equation of isobaric process is pressure by temperature is equal to constant. Pressure by temperature is constant. Right? No, not reality, because this was process equation of another thing. And also pressure is constant, then constant by T. Temperature can be anything else, so we get the volume. Now this is constant because pressure is already 0. This we know. Right? So I have written some very important formulas for you over here. There are many of them. You won't be able to remember all of them. So these are some important formulas taken from NCERT line by line. First of all, Cv by Cv is equal to gamma, as you all know. Now this is a new one. Gamma is equal to 1 plus 2 by F, where F is degree of. Now Cp is equal to R plus F by 2, derived from Cp minus Cv is equal to R. We know about Cp minus Cv is equal to R. Now delta Q is equal to delta U is equal to N Cp delta K, because it is constant pressure, that's why N Cp, not Cv. Now the is P into delta V, that means P into T2 minus V1 and NR into T2 minus T1. As we all know, delta T, that means T2 minus T1, and P into V2 minus V1 when we derive it. So there are many of them which we will do in further of our videos, but this is enough for today. Alright, so I hope that you liked the video. So in the proceeding chapters, we will learn about new things like calorimetric and some heat engine, steam engine, petrol engine, diesel engine. All these videos are coming. Some new type of processes like reversible and irreversible processes and cyclic processes. All of these are in your syllabus. So So maybe you think that why haven't I tell you about irreversible cyclic processes? It's because you won't be able to understand. There will be some new concepts like second law of thermodynamics involved in all of them. Then between that we have to learn about heating. Then there is a very big topic. Thermodynamics is a very big topic in itself, so we have to be very patientful to learn it in physics. And we hope that we don't do thermodynamics of physics and thermodynamics of chemistry line by line in same time, because then curd will be made in your mind